If you could take a selfie of our galaxy from the outside, point a camera at the Milky Way and shoot, where exactly would you aim to find us? Most people point toward the center, toward the bright core, toward where the action is. They're wrong. We are not at the center of the solar system. We are not at the center of the galaxy. We are not at the center of anything. And when you actually map out where we sit layer by layer, from our orbit around the sun to our address in the cosmic web, the picture that emerges is stranger and more precise than most people realize. In the last few years, the ESA Gaia mission has mapped the positions of over 1.8 billion stars with a precision never achieved before. What it revealed about our location changed several things astronomers thought they knew. This is where we actually are. Start small. The Earth is the third planet from the Sun, at an average distance of about 93 million miles. That distance has a name, 1 astronomical unit, or AU. It is the baseline measurement for everything else in the solar system. That distance is not arbitrary. It places Earth in what astronomers call the habitable zone, the range of distances from a star where liquid water can exist on a planet's surface. At 93 million miles, Earth receives enough solar energy to keep water liquid, but not so much that it boils away. Move in by 10% and the oceans evaporate. Move out by a similar margin and they freeze solid. We exist in a narrow band. The solar system itself extends far beyond the planets. The Kuiper Belt, the region of icy bodies where Pluto lives, stretches from about 30 to 50 AU. Beyond that, the Oort cloud, a theoretical spherical shell of icy bodies, may extend as far as 100,000 AU, nearly halfway to the nearest star. The solar system is not where the planets end. It is where the sun's gravitational influence finally gives out. The nearest star to our sun is Proxima Centauri at just over 4.2 light-years away. 1 light-year is about 5.9 trillion miles. At the speed of the fastest spacecraft humans have ever launched, the Parker Solar Probe, and its closest approach to the sun, it would take approximately 6,000 years to reach Proxima Centauri. The nearest star is not close. The solar system is an island, separated from its neighbors by distances that dwarf anything within it. The Milky Way is a barred spiral galaxy, a flattened disk of stars with a bright central bar and spiral arms winding outward from it. Its diameter is roughly 100,000 light-years. Its thickness at the center is around 12,000 light-years, thinning to a few hundred light-years in the outer disk where we live. The Sun sits about 26,000 light-years from the galactic center, a little over halfway out from the core to the edge. Not at the center, not at the periphery, somewhere in between, in a relatively quiet region of the outer disk. Here is the detail most people miss. The Sun is not in one of the Milky Way's major spiral arms. It sits in a smaller structure called the Orion Spur, a minor arm, a bridge of stars and gas connecting the larger Sagittarius arm and Perseus arm. We are in a galactic backwater, a secondary branch, not a main thoroughfare. The Gaia mission has refined our understanding of exactly where the spur begins and ends, how it curves, and how it connects to the major arms. What Gaia confirmed is that the Orion Spur is real. It is distinct, and we sit near its inner edge, with the dense Sagittarius arm a few thousand light-years closer to the center, and the Perseus arm a few thousand light-years further out. The Sun completes one orbit around the galactic center roughly every 225 to 250 million years, traveling at about 134 miles per second. Since the Sun formed 4.6 billion years ago, it has completed approximately 20 orbits. The entire recorded history of human civilization, every empire, every war, every written word, fits inside a fraction of a single degree of that orbit. The ESA Gaia Space Telescope, launched in 2013, has been measuring the precise precisions, distances, and motions of stars across the Milky Way with a resolution equivalent to measuring the diameter of a human hair from 620 miles away. Its third major release in 2022 contained measurements of over 1.8 billion objects. What Gaia found was not a tidy, symmetric galaxy. The Milky Way is warped. Its disk bends upward on one side and downward on the other, like a vinyl record left in the heat. The warp becomes pronounced in the outer disk, the region beyond our position. Astronomers believe it was caused by the gravitational pull of satellite galaxies, primarily the Large and Small Magellanic Clouds, tugging on the disk as they orbit. Gaia also revealed the scars of a violent past. Roughly 8 to 11 billion years ago, the Milky Way collided with a smaller galaxy now known as Gaia Enceladus. The evidence is encoded in the orbits and chemical compositions of stars that were absorbed during that merger. Stars that now populate the inner halo of our galaxy, moving on orbits that betray their foreign origin. The Milky Way we live in is not pristine. It was built in part by consuming other galaxies. Our own position in the Orion Spur, at roughly 26,000 light-years from the center, sits well outside the zone of maximum disruption from that ancient collision. The outer disk, where we are, is younger and calmer than the inner regions. That matters more than it might seem. Enjoy Deep Fact Space Stories? Hit subscribe and activate the notification bell. Otherwise, YouTube will not show you the next videos, and you'll miss what we uncover next. There is a concept in astrobiology called the galactic habitable zone. It is the idea that not all positions within a galaxy are equally suitable for life, and that our position might be precisely, perhaps even uniquely right. Too close to the galactic center, and the problems multiply. The stellar density is extreme, stars packed hundreds of times more tightly than in our neighborhood. Gravitational interactions disrupt planetary orbits. Supernovae are frequent, and close ones sterilize nearby planets with bursts of radiation. The supermassive black hole at the center, Sagittarius A star with a mass of about 4 million suns, drives periodic eruptions of high-energy radiation that flood the surrounding region. Too far from the center, and the problem reverses. The outer disk is poor in the heavy elements, carbon, oxygen, silicon, iron, that planets and life require. Those elements are forged inside stars and distributed through supernova explosions. The outer galaxy has had fewer generations of stars, fewer supernovae, less chemical enrichment. Life requires raw materials, and the outer disk runs short of them. Our position, 26,000 light-years out, in a relatively quiet minor arm, sits in the band that avoids both extremes. Not too irradiated, not too element-poor. The galactic habitable zone is estimated to extend from roughly 13,000 to 33,000 light-years from the center. We are inside it. We may not be at the center of the galaxy, but we might be at exactly the right distance from it. The Milky Way is not alone. It is one of more than 70 galaxies in a cluster called the Local Group, spanning roughly 10 million light-years. The Local Group has two dominant galaxies, ours and the Andromeda Galaxy, also known as M31, about 2.5 million light-years away. Andromeda is approaching us at roughly 68 miles per second. In approximately 4.5 billion years, the two galaxies will collide and eventually merge into a single elliptical galaxy. The stars within each galaxy are so widely spaced that very few individual stars will actually collide, but the structure of both galaxies will be completely disrupted. The spiral arms will dissolve. The galactic address we have now will cease to exist. Beyond the Local Group, the structure continues to scale up. The Local Group is part of the Virgo supercluster, a collection of galaxy groups spanning about 110 million light-years. And the Virgo supercluster is itself just one lobe of an even larger structure called Laniakea, a supercluster of superclusters containing the mass of roughly 100 million billion suns, spanning 520 million light-years. We sit near the outer edge of Laniakea, in a region that is slowly being pulled inward toward its gravitational center, the Great Attractor, a concentration of mass 150 to 250 million light-years away, toward which everything in our supercluster is drifting. We are not at rest. We are falling very slowly towards something we cannot see. There is one consequence of our position that is immediately visible on any clear night, and almost nobody thinks about what it means. The whitish band that crosses the sky, the Milky Way as we see it, is not a view of the galaxy from outside. It is the view from inside. We are looking at the galactic plane edge-on, from within it. What we see as a diffuse band of light is the accumulated glow of hundreds of billions of stars in the disk, all too distant to resolve individually, blurring into a continuous glow. We cannot take a photograph of the Milky Way as a whole from the outside. Every image you have ever seen of a spiral galaxy that looks like ours, The perfect overhead views, the glowing arms, is either a picture of a different galaxy or an artist's reconstruction based on measurements. No human instrument has ever seen the Milky Way from above. We are inside it, looking sideways. If you stand outside on a dark night and look at that band of light overhead, you are looking through roughly 26,000 light-years of disk toward the galactic center, toward Sagittarius A star, hidden behind clouds of gas and dust so thick that visible light cannot pass through them. The black hole at the center of our galaxy is less than 26,000 light-years away, and we cannot see it with the naked eye, not because it is dark, but because the galaxy itself blocks the view. We are inside the picture we are trying to draw. Our location in the galactic habitable zone has a direct implication that rarely gets discussed. It shapes what kind of planets exist near us, and therefore what kind of life we might find. Stars in the inner galaxy, the bulge, the dense stellar bar, tend to be older, metal-rich, and surrounded by planets that formed earlier in the universe's history. But they also live in a far more violent radiation environment. Older stars are more likely to have exhausted their fuel and exploded. The sterilization risk is higher, the stability of planetary systems over billions of years, the time life seemed to need, is lower. Stars in the outer disk, where we are, formed more recently and in a gentler environment. Our Sun is a relatively young star, 4.6 billion years old, in a galaxy that is 13.6 billion years old. It formed in a region with enough heavy elements to build rocky planets, but far enough from the center to avoid the sterilizing radiation that dominates there. Some researchers argue this makes our type of neighborhood, a quiet outer spiral arm, mid-disk, mid-galactic radius, the most probable address for complex life anywhere in the Milky Way. Not the center, not the edge, the middle distance in a minor arm, in a cleared bubble of gas around an unremarkable middle-aged star. If that reasoning is right, then the nearest intelligent civilizations, if they exist, are probably not in the galactic core or in the sparse outer reaches. They are probably in neighborhoods statistically similar to ours, similar distance from the center, similar stellar age, similar chemical enrichment. The search for life is, in part, a search for places that look like where we already are. We may be typical, and typical in this context might be exactly what life requires. Here is the complete address. Third planet from a middle-aged yellow dwarf star. That star sits 26,000 light-years from the center of a barred spiral galaxy, in a minor arm called the Orion Spur, inside a cleared bubble of gas carved by ancient supernovae. That galaxy is one of more than 70 in the Local Group. The Local Group is one lobe of the Virgo supercluster. The Virgo supercluster is one of perhaps 10 million superclusters in the observable universe. Carl Sagan called Earth a pale blue dot. The description is accurate, but incomplete. It captures the smallness without capturing the precision. Earth is not merely small, it occupies a very specific position in a very specific hierarchy, and that position, as far as we can tell, is one of the relatively rare ones where the conditions for life are met. We are not at the center of anything. We are not the reference point around which the universe organizes itself. But we are also not random. The position we occupy in the right zone of the right galaxy at the right time in its history, in a cleared space of reduced density, is, as far as science can currently determine, a genuinely unusual configuration. We are not the center of the universe. We are something stranger. We are in exactly the right place. Now you know where we are, but what happens the moment you leave? If you travel straight up from Earth right now, what do you actually pass through, layer by layer? Watch what's directly above Earth if you travel right now to find out.